Welcome everyone. The topic for our today's presentation is virtual memory and mapping techniques. My group members Shubham Roy is going to explain on direct mapping. Siddharta Banerjee is going to explain cache mapping. Shilajit Shah is going to explain associative mapping, and Rahul Manna is going to explain set associative mapping. Introduction, which is the virtual memory, which I am going to explain. My name is Rohan Sarkar. Virtual memory is a storage allocation scheme in which secondary memory can be addressed as though it were a part of a main memory, which basically means that virtual memory is used to give programmers the illusion that they have a very large amount of memory, even though the computer has a small memory, which basically translates that suppose there's a finite amount of RAM, so the memory can run out, especially when multiple programs are running at the same time. A system using virtual memory can load larger programs or multiple programs running at the same time, allowing each one to operate as if it has infinite memory and without having to increase the RAM. As part of the process of copying virtual memory into physical memory, the OS divides the memory into page files or swap files that contain a fixed number of addresses. Each page is stored on a disk, and when the page is needed, the OS copies it from the disk to main memory and translates the virtual address to real address. Virtual memory is valuable in computer architecture that allows you to run large sophisticated programs on a computer even if it has a relatively small amount of RAM. That is one of the main benefits of using a virtual memory. Next, the topic on cache memory, my teammate Siddharth Banerjee is going to explain.
Hello, my name is Siddharta Banerjee and I am going to tell you about cache memory and its different mapping techniques. So, what is a cache memory? A cache is a small and very fast temporary storage memory. It is faster than RAM, and the data that are most recently or most frequently used by CPU are stored in cache. And what is cache mapping? Cache mapping is the method by which the contents of main memory are brought into the cache. There are three types of mapping techniques: direct mapping, associative mapping, set associative mapping. These mapping techniques will be explained in detail by my fellow friends. Thank you.
Hello everyone, my name is Shubham Roy and I am going to explain direct mapping. First of all, what we need to understand is what is mapping. The transfer of data as a block from main memory to cache memory is referred to as mapping process. Now there are three types of mapping: associative mapping, direct mapping and set associative mapping. I am going to explain direct mapping. What is direct mapping? In case of direct mapping, instead of storing the total address information with data in cache, only a part of address bits is stored along with data in the direct cache mapping. So let us assume that cache memory can hold 2 to the power of m words and main memory can hold 2 to the power of n words. This means that the CPU will generate n bit memory address. The n bit memory address is now divided into two fields: the lower order m bits for the index field and the remaining higher order n minus m bits for the tag field. The direct mapping cache organization uses n bit address to access the main memory and the m bit index to access the cache. So the cache is divided into cache blocks, also called cache lines. A block contains a set of contiguous address words of same size. Each block is typically 32 bytes. We know that the data is transferred from main memory to cache memory as block. Now the index field is divided into two parts: the block field and the word field. So this is direct mapping. And now what are the merits and demerits of the direct mapping? Let us know. This is the simplest type of cache mapping, since only one tag field is required to match. That's why it is one of the fastest cache. Also, it is less expensive cache relative to the associative cache, because of instead of storing all the 16 bits of the address, only tag value of 8 bits is stored along with the data word. Now what are the demerits of direct cache mapping? The hit ratio is not good. It needs to frequent replacement of data tag value, because there is a fixed cache location for any given block. For example, if a program happens to be reference words repeatedly from two different blocks that map into same cache block, then the blocks need to be swapped in continuously, making hit ratio to drop. Thank you.
Okay, hello viewers. My name is Silajit Saha of roll number 11500216011. In this recording, I am going to explain a small part of the PPT of mapping, and I'm going to explain associative mapping. Associative mapping is also known as full associative mapping. Here the main fundamental thing is that any frame from the main memory can be mapped to any space in the cache memory, which is also called lines. Means any frame can be mapped to any of the lines present in the cache memory. Now, as it is mapping any of the frame to any of the line, so it's also create a problem. The problem is what? How how this processor will understand that which part of a frame is mapped to which part of the line. So for this, we have to apply some algorithm or apply some technique to identify that which frame is placed in which lines. Now, to overcome this problem, we placed comparator in all the tags, means we place comparators in all the lines present in the cache, and if a hit occurs, then the comparator will respond and all the connection of the comparator goes to a OR gate. If the OR gate responds to 1, that means it's a cache hit, otherwise it's a cache miss. Now another important thing about associative mapping is it also overcomes the problem which was faced in direct mapping. The problem was that instruction having same line number but different tag cannot be placed in the cache. This problem is overcome in associative mapping. In the address format, it's little different from the direct mapping. In direct mapping, it was having tagged, then line number, and then offset. But in associative mapping, it's having only the offset and tag field. Now, besides its advantages, it also has some disadvantages. The main disadvantages in associative mapping is that the hardware complexity become larger, as because in each lines we have to place one comparator, right? So as more number of comparators required, the complexity of the hardware becomes more. That is, the cost becomes more. So this is a major flaw in associative mapping. So this is all about associative mapping. Thank you.
Hi, I am Rahul Manna and I am going to explain set associative mapping. This mapping technique is intermediate to the previous two techniques. Blocks of cache are grouped into sets and each set contains a number of lines. A given block maps to any line in a specific set. For example, let's say there are 2 lines per set. Then it will be called two-way set associative mapping. A given block can be in either of 2 lines in a specific set. So obviously it is much easier to simultaneously search one set than all lines. This slide will give you a better visualization on how exactly this mapping procedure is done. I would recommend you to pause this video here and carefully go through the diagram for better understanding. This will be more clearer when we will see an example. Here, the main memory address is grouped into 3 parts: tag bit, set bit and block offset. Here in our example, we are given a 64 KB cache, that means 2 to the power of 16 bits, so the total address is of 16 bit and it is divided as 9 bit for tag field, 13 bit for set bit and 2 bit for block offset. Let us take an address 16339C. It is in hexadecimal form, so if you convert it to binary, you will get this. As tag is of 9 bit, so it will be 000101100. Similarly, block offset bit will be plus 2 bit, that is 00, and the rest part is set bit. So in this way, searching overhead also gets reduced in this process because the search is restricted to number of sets instead of number of blocks. So that's all for set associative mapping. Thank you.
So that's our presentation on virtual memory and mapping techniques. If you like the video, please comment below. And if you have any doubts or queries regarding the presentation, you can comment below.